Alright, today we're going to be building and evaluating a very simple model, and we're going to see how accurate it is using a confusion matrix. Now, contrary to common belief, confusion matrices are not actually that confusing. So let's go ahead and load in our data, and we're going to use miles per gallon, and we want to predict in this project whether a car is fuel efficient or not. So I've gone ahead and written a dummy variable. Basically, if the car is fuel efficient, we give it a 1. If it's not, we give it a 0. Now we're going to go ahead and delete that original miles per gallon variable because we don't need that anymore. Now, one of the big components of creating models is reserving some information for training and some information for testing. Now, I've created a sample that takes about 70% of the data and gives it to training, and the remaining 30% I've assigned to testing. What this does is gives our model 70% of the information to train on or create a way of predicting new values off of, and it gives 30% for us to see how good that model is performing. This is the most common split, although there are many other ways to do this. This is by far the fastest. Now we can get into writing our model. This part is actually the easiest part. All you do is write one line of code. We are using a logistic regression model, which will assign probabilities to our outcomes, and then we can see whether they are going to be fuel efficient or inefficient. Now, right here, this predict function has used our model to predict values for our test data set. Now, because the logistic regression assigns probabilities, we have to go ahead and label them once again for our output. Now, here comes the best part. We're using a table to now see our confusion matrix. Now, I will zoom in to this thing right now, but going through it really quickly. The top row, these are our actual values. These are our predicted, and the left side, these are our actual ones. So take a look at this column right here. This means our model has predicted 6 values for 0. However, those 6 values are not all actually zeros. Some of them are actually 1s. See, only 5 of those are actually zeros, and one of them is actually a 1. So 5 are fuel inefficient, and 1 is fuel efficient. So what we want to do here is add up our actual correct predictions, which are represented by the diagonals, and then divide them by our total. So these are our total values right here. That gives us an accuracy of 90%. Now, this is the correct way to interpret your confusion matrix. The most important part of it's usually given by the diagonals, so you can see the accuracy from that. So this, from start to finish, is coding your data set, training a model, and then evaluating it to see how accurate it is. It's not too many lines of code, and it's actually quite intuitive, and this is obviously a very simple case, but this can be expanded to a much more robust practice. So I hope this was helpful, and thank you.